also share this with your friends so that they can join in. Okay, there is some issue with the lighting. All right. So I hope everybody can see me and hear me, right? So we,
Yes, we can see you.
all right. Okay, so good evening, everyone, again, and welcome to first ever CNCG Dehradun, which is happening in the city of Uttarakhand, land of God, you all know. And it's our privilege to start this. And very happy New Year to everyone. And I hope your goals to New Year are just kicking off and you are about to start something good. Some of you might be graduate looking for jobs, some of you are still pursuing. So, all in all, most of you are aware about cloud native, right? So, we will in this like seminar will be exploring about cloud native and how we can you know enhance this cloud native local chapter of Dehradun. Okay, so I'm very excited, very thrilled, and this community is for you guys, cloud native enthusiasts, developers, innovators, because you are the future of like future engineers, and so you will make this you know your parents really proud. So now to talk about our team, and I would like to congratulate like, all the volunteers who made this possible. Without them, it won't be really possible. Okay, and so yeah, like I said, myself. So I will introduce. I am Ashutosh. Ashutosh Kandpal, and I have over a decade of years of experience in infrastructure, then cloud native and DevOps. So I have led multiple projects, and I am like 15, more than 15 certification I have under my belt, which includes Oracle, AWS, Azure, and I have like CK and CKS as well. So just like since 3 4 years, I'm starting into the Kubernetes domain. And my co-organizer is Mohit, and he's a very talented person, and he's like studying currently, and he's having a major in computer science and exploring the cloud technology, right? So today's agenda will be like will we have three speakers lined up. First, we have Arpit Agrawal. Do we have Arpit Agrawal here from Cube Simplify? And he's working as a DevRel at Cube Simplify. So I welcome you. Then we have Krish Aryan, who is like a software engineer at Webness, and he is also a GSOC contributor. So he'll be letting you navigate the GSOC and how you can crack that. Then, last but not the least, we have Murli sir, and he is founder and CEO of Klahan Technologies, which is a company working in cloud space, and they have you know multiple projects under their belt. They're into corporate training also, and yeah, so that is there, and we will be sharing more insights on this cloud native DevOps, and I would encourage everyone to ask their friends to join, and then yeah, so I would hand over this to the first speaker. So Mohit, we should start or we should wait for some people?
I think we can wait for 2 minutes. No,
All right. Okay, so I would like next time we would be doing the offline event. So this is just the first time we were running out of schedule. So that's why. But next time we will plan something big in Dehradun. So all the local folks be ready to have some encouraging like session, and we'll make it big. And this is just starting. So I would encourage you to share more with your friends, and also tag us in the LinkedIn, follow us, so that we can get more motivated about this cloud native thing. So in 2 minutes, like we can start. Let other people also join in. So I can see only 16 people. Kindly, guys, add some more. All right, and okay, so I'll now hand over to this like the speaker, Arpit, and you can start. People will join in. All right, over to you, Arpit.
Yeah, I have Ashutosh. Yeah, let me know when my screen is visible.
Yeah, I can see that. I can see. I can see
Yeah.
your screen.
Yeah.
So
So, hey
you can
everyone.
start with first of all your
Okay.
introduction, then this.
Yeah, why not? Yeah. So, hey everyone. I am Arpit, and I am currently a DevRel at Cube Simplify. So, Cube Simplify is a YouTube channel which basically simplifies Kubernetes and CNCF landscape for all of us. So our today's topic is that how can someone get started with like as a contributor in the Kubernetes ecosystem? I know it can be a little bit of overwhelming, but stay with me for the next half an hour, and you can start with your first like your first contribution. So yeah, so this is what our today's agenda is. So I will explain to you what is Kubernetes and how the Kubernetes community structure is lined up, and what does it actually mean to be a contributor, and how can one start contributing. Other than that, I would also be like uh, presenting some of the current work opportunities, like kind of issues and what areas can anyone contribute to. These includes both tech as well as non-tech. So I hope by the end of this talk, uh, anyone of you can get started with the Kubernetes community. So let's meet the Kubernetes community first of all. So this is basically what the community look like. The photo here is from the Open Source Summit North America 2024, and here are some of the stats which I have pulled like while making the slides. So currently in Kubernetes, we have around 93,000 contributors, and those 93,000 contributors have made over a 4 million contributions. And all these contributions are reviewed by just 7.5K reviewers. So these stats are basically, there are tools from where you can get these stats, and Kubernetes also publish a report every year. So you can find these stats. Apart from this, here is a diagram. So this diagram shows like Kubernetes is basically here from 2014, and from 2014 to 2023, like at the end of 2023, Kubernetes has gained around 80,000 contributors, and that's a lot, and that's basically uh, is a symbol like Kubernetes is doing very well, and people are adopting it. So yeah, so now let's move on. So there's a misconception like for contributing in the Kubernetes community, someone needs to be an expert or a pro in Kubernetes and DevOps. So that's not true entirely, but I would say skills never hurt. If you have these kinds of skills, those are very like that is very awesome. But you don't have that, and you want to contribute, so you are also welcome. But what you need to know is what is Kubernetes, because you are going to contribute to the project, so you need to understand what the project does. So, in a nutshell, what Kubernetes is it is a tool for orchestrating containers, and it is open source. Now, when I say open source, I basically means that it is made by people around the world, and some of whom are paid to work on it, but many of whom are volunteers. So I consider myself as a volunteer because I don't get paid to contribute in the Kubernetes ecosystem, but uh, some companies do pay their employees to contribute to open source. So that is very cool. I know it's cool. And When I say Kubernetes is open source, that also means that its code is publicly available under an open source license. And that license basically describe exactly who, when, and how the software and its source code can be used. So this is like very basics of what Kubernetes is. But let's explore what Kubernetes do in a nutshell. Like what Kubernetes does. So in the first snapshot, this is basically a business. Any business you can say, and businesses can have a tons of apps. Like they can have their websites, they can have their payroll applications, they can have their inventory management system, etc. And the list goes on. And they also have too many computers. Yes, this stack is a computer. It's a server, but every server is a computer, so it is a computer. So what Kubernetes enables to for businesses is now businesses can say to Kubernetes, "Hey Kubernetes, here are the computers that we have, and here are the apps that we want to run on them." So you can decide what apps to run on which, and what is the specific hardware they might need. And now this is the responsibility of the Kubernetes to run those apps on the specific hardware and the servers. Here in this case, the servers are local. I assume that these servers are owned by the business itself, but this you can replace the servers by AWS or Azure Cloud, anything. So servers can be anywhere. Also, Kubernetes provides some extra functionality, like if someone wants to upgrade their version of applications, Kubernetes also provides to do it. So this is what Kubernetes is, and this is what like this is the minimum what you need to know about Kubernetes to for getting started. You can explore it more in the technical side. That is all up to you, and I would encourage you to do that. But this talk is about how you can involve in the community. So let's focus on that. So now we have the Kubernetes community structure. So first thing, uh, all the Kubernetes community is on the Slack, and this is the basic community structure. And on the top of it, you can see we have Cloud Native Computing Foundation. And if you if by a movie analogy, you can say CNCF is the producer over here. But no, so CNCF basically makes us of all the funding and basically manage various guidance and services. Apart from that, CNCF itself is a non-profit organization. So this is on the top of it. But then we have the steering committee. So steering committee is an elected body. So every year Kubernetes there's an election where Kubernetes org members vote and select steering committee. Steering committee basically consists of 7 members, and every year the elections happen in forms of 4 and 3. So last year 3 members got elected. So this year there will be 4 members which are being elected. Like they will be elected in this year. So this is how this runs. But Kubernetes as an open source project have lot of things, and that basically means we need to divide the interest. And when people have very specific interests, like in case of six, so six are special interest groups. So six, you can say they are a team. So folks with a specific interest, like someone is very interested in architecture, and folks who came together and maintain a very specific scope of the project. Now, let's suppose there are the other bunch of folks who said like, okay, we will be taking care of the documentation, or we will be taking care of the stuff which basically deals with the Kubernetes architecture. So they form a SIG. That's an special interest group, and that SIG is basically responsible for that core functionality. And then we have working groups. Now, working groups is an idea where if there is a issue which comes under the scope of lot of SIGs, like there's a issue which also comes under the SIG architecture because it is an architecture issue, but it's also come under SIG node. So what they will do, they will collab and will make a working group, and then they will solve it. So working groups are, you can say, they are owned by a SIG at the end, so they are a sub part of the SIG, but they don't own any code, or they don't own anything. They are very specific for an issue, and after that issue is resolved, the working group will disappear. So this is about SIGs and working groups. You can consider SIGs as the team, and for example, SIG architecture will own the entire code base for uh, the Kubernetes code, which basically deals with the Kubernetes architecture, and SIG docs will own the whole documentation stuff, uh, like the whole documentation for the Kubernetes documentation. So this is what SIGs are, and I told you about working groups and what are sub projects. So not every, but most of the SIGs have sub projects. This is how they divide their work into. So every SIG has some responsibilities, and they divide it into some projects. Like for example, say the contrib backs comps deals with the communications as well as they deal with the associates. So they have two projects for that. So yeah, let's move on. So this is about the SIGs and the structure. So currently we have over 24 SIGs and 7 working groups and 3 committees. Again, you can get more information about this from this link. Feel free to go on that. Yeah. So we can further divide SIGs and working groups according to their scopes. Now, there's a project scope, basically any SIG that deals with the very core functionality of the project. Here in case Kubernetes, so if any SIG is dealing with the very core functionality of the Kubernetes, they come under the project scope, and they basically affect the entire project directly. And obviously they need to collaborate with other groups as well. So that is what the project scope is. And the horizontal scope is basically having a deep and broad technical focus. Basically the SIGs which uh, owns core functionality from an architecture perspective comes under this. And these are basically depend on the SIGs which are comes under the project groups. And then we have vertical groups. They also have broad technical specifics, but they basically depends on the horizontal and project group SIGs to work with. So this is the various scopes. And here is a snapshot of all the SIGs according to their scope. So you can look it into it, and you can basically get a glimpse of how one can contribute. Now, this is an important slide because here we are focusing on why do you want to contribute, and it is very important to have a clear vision in mind. Like, why do you want to contribute? Either your job requires it, or you want to grow some specific career-related skills, or you want to network and increase your connection. Or yeah, Kubernetes is a cool technology. We all know that, and there's no doubt in that contributing is super cool. But or there's a case that you enjoy being part of the community, but I would say that you need to think very carefully about what do you want and why do you want to contribute. uh, Now the reason why I am telling this is because if you can tell someone clearly what do you want, they can help you with that. So you need to decide it, like what is the reason why do you want to get involved with the Kubernetes ecosystem, and that's how you communicate with someone. So if you are reaching someone out and you are very clear on like what do you want from them, they can help you with that because again, folks are very busy plus different time zones, and it can save you time and it can basically help you to move ahead. So yeah, do give us out on why do you want to contribute and don't get misled. So yeah. Now, let's before doing a contribution or getting like thinking about doing a contribution, first talk about what do you mean by a contributor. So basically, anything you do to help Kubernetes community grow uh, counts as a contribution. It does not like it is not necessarily that it ought to be GitHub tracked. Like it should not like it is not necessarily that it is code, but everything counts as a contribution. Like this is an specific thing from the Kubernetes new contributor orientation session. I have pulled out a snap, and they basically say any work that you do to support the open source Kubernetes project counts. And it can be as simple as taking notes during community meeting, or like asking a question on a Slack, or implementing a new feature or a part of a feature, or commenting on caps, like their Kubernetes enhancement proposal or issue, or even writing a blog post. These all count as an contribution. Now, I cannot list all of them here, but even discussing on the Slack and being available for everyone also counts as a contribution. But these are some of the way new folks want to get involved. So yeah, now this is the contributor ladder, and I can say most of you are here. You are a non-member contributors, and this is how you will go above. Now, no way with this ladder I want to implicate like if someone is a member they are not good or someone is an approver they are good. But this is how this things look like. And again, there are various levels of being a contributor. So Uh, you might remember I have told you about contributors and reviewers in the previous snapshot slide, but starting at the very bottom, if you are a non-member contributor, that is fine. But if you want to do something more, you might want to be a member, and that is basically what Kubernetes org membership is all about. Uh, so yeah, if you contribute to the community in any way, that you might be what we call is a non-member contributor. That basically means that you pop into the community and contribute likely in a small and disconnected way. So that is what non-member contributors do. You are in the community, you are visible, but you are contributing in a disconnected way. Maybe you contributed a little now and then after 3 months, but if you want to like really get involved and the community you want to go for the org membership. So when you got the org membership, that is basically how you become a Kubernetes community member. And how you will get the org membership, I will talk to it about right now. So basically an org member refers to a member of the Kubernetes organization on GitHub. Basically, your GitHub username will be listed in a file that in a list of members, and that is how you become an Kubernetes org member, and you will get an invite from the Kubernetes community to join the GitHub. So there are some privileges of being an org member that you can interact with the Kubernetes contributors, and while taking part in the meetings, you can even edit the project code. So there's a project board on GitHub which only Kubernetes members can edit. So yeah, and you can have comments, and now you can be a reviewer and stuff. So you will be ready to become a Kubernetes org member when the contributors you work with regularly are familiar with your work and will vouch for you as sponsors on a request for membership. So for becoming an org member, you need to file a request, and that request has to be sponsored by uh, two uh, folks, which need to be our reviewers. And if they sponsor you, then your request will be accepted and you can become a Kubernetes org member. For me personally, I have written two blogs, and after that, the chairs of the Contrabex comps have sponsored me to become a Kubernetes org member. So this is how I become a Kubernetes org member. And if some of you wants to become a Kubernetes org member, my simple advice would be like, if you are contributing to something like writing a blog, or you are contributing to docs, or you are enhancing a feature, that is way enough. What you need to do is you just need to ask it out after filing like a couple of contributions, and everyone would be happy to help you. So now, after the org member, when your trust level came to a point where six years think that you might handle some more responsibility, and that is completely on you whether you choose to pursue it or not. But once you have engaged in an area for a while, you might have enough knowledge to review contributions. Like now you have experience, for example, writing a blogs, like you have written a couple of blogs. So now you can also review them. So now you can approach towards being a reviewer. So you will review them, put comments on them, and eventually, like after becoming a reviewer, eventually you might be trusted enough to have a final say on whether some code should be merged, or a contribution that is accepted or not and displayed on something. Like for example, every blog goes on the Kubernetes community site. So you can also now approve them after being a reviewer. So that basically depends how long you are engaging with the community and what sort of trust level you have built. But after reviewing, you can move on to the approver. Again, there should be like you need to maintain a good trust level so that someone can trust you that you are approving the right things. But after being an approver, if you like become a strong expert in a specific area, then you can be highly trusted, and uh, your expertise can be trusted, and you might take on few exciting responsibilities, and that is what uh, a sub project owner is. So basically now you own a sub project within a SIG, and now you are now basically leading that sub project. And same on goes for the sub project lead, where there are like after being a sub project owner, you can move to sub project lead. And if you have contributed enough and now you have a certain trust level in the community that, okay, everyone now knows you, then you can also become a 6 year tech lead. So again, uh, I would again like to remind you, like this contributor ladder is not a definite part to contribute to Kubernetes, but this is something because you will came across these terms like SecChair, sub-project lead, sub-project owner, approver, reviewers, or members across the GitHub when you are engaging with the community. So it is very good to know like what is like what basically mean by every single term, and by saying you can tell, okay, this person is a stick chair, and then you can reach out based on what you want. So let's move on to the next slide. So this is where how to basically start contributing. And this is the very simple step. Please don't go to the GitHub and open the Kubernetes repo. It is super overwhelming, and chances are you will get lost. But the correct way to get started with Kubernetes is by joining a stick. So basically, it's the fastest way. So try to find your interests and join a SIG. And joining a SIG itself is not enough. What I would recommend is you should attend meetings, and I can vouch for your first couple of meetings will go over your head. But after attending couple of meetings, you will get a hack of like what is going on, what is going around, and you can decide. You can interact to folks on how to contribute. And you can also join the KDev mailing list. It's the Kubernetes Developer Google group. So this is where all the announcements came. And yeah, joining the Kubernetes Slack is a no-brainer because that is where everything happens. So yeah, now uh, let's. I will give you a quick SIG repo walkthrough. Let me unpresent my screen for the entire screen. Yep. I hope my screen is visible, right? Hello, my screen is visible, right?
Not now. Earlier, now I yeah, now it's visible.
Yeah. So this is the Kubernetes community repo, and you can find there's a repo for every SIG, as you can see. So you can basically you can explore the SIGs right there, and you can do like you can search based on your interests, and there are a lot of things over there. But let me give you a quick overview of how would you sorry, like how would you navigate it. Let's select one. Yeah. So I selected the communication one. So let's select something else. We can go with SIG because it is relatively popular. And what you can see here is first thing what you will see is there are meetings. So here are all the meetings that are listed. There is another way known as Kubernetes Community Calendar where all the meetings from all the SIGs are listed. But these are the very specific meetings that this SIG runs, and with the specific time zones and agenda notes, you can also find meeting recordings over here if you want. And next, what you are seeing is there are SIG chairs. So these are the folks who is responsible for that SIG, like they are taking care of that SIG. So if you want to contribute, you can reach them out in this public SIG channel, or you can ask them out. And these are the technical leads. So these are basically responsible for the technical stuff going behind the SIG. Apart from that, here is a contact information. Like you can find the entire teams which are responsible for every single stuff. Now, SIG docs has a lot of them because Kubernetes documentation is in many languages. So you can find for the each specific language as well. And here is a team for like blog maintaining and stuff. And you can also find all the sub project listed over here. So basically, SIGDocs own Kubernetes blog projects where they maintain and write blogs over there. Then there is an localization one where this project is basically responsible for localizing Kubernetes documentation in local languages. And then we have the website. This is basically responsible for the Kubernetes website to run on. This is how you navigate a SIG. And let me give you a quick overview of Slack as well. So this is the Kubernetes Slack. I hope it's visible. So I am the part of SIG and this is how it looks. So you can reach to them out here as well. You can just ask by tagging the SIG chairs. You can go to the repo and find who are the SIG chairs, and you can just reach them out that hey, I want to get started. I have this kind of an experience, and I would like to contribute. What are some areas what I can contribute to, and I also have gone through the repo, and I found this project interesting. So how can I get started with that? This basically shows that you have researched a bit and you are asking a like good question. So everyone is happy to help, and everyone, like, there's a almost 100% chance that Cheers will reply, but do make sure that folks are from the different time zones. So there might be a case that you can get a reply late, or there might be a case where you need to ping them again. But makes and like this is a time zones thing. Like because folks are very busy, they tend to like lost track of couple of things. So that's a no biggie. Yeah. So now let's move on. So here is the Kubernetes community calendar I have talked about. So Kubernetes community calendar is literally a calendar which basically lists all the meetings across the six, and you can find every one of them here. So you don't need to maintain a list of meetings or whatever, or you don't need to remember it. You can just go to the Kubernetes community calendar and you can find a meeting and go and join it. So that is what Kubernetes community calendar is. So now let's move on to the current work opportunities, and these are some of the evergreen opportunities which are always open for anyone. Most of them require no experience out there. So most things have meeting note taking available. Now, why do you want to do that? Because you want to like tell everyone that you are there and you are presenting. So that is one thing. Apart from that, I would say that uh, note taking also helps you to figure out how meetings are run. Because when I have joined the Kubernetes comms, I also done the meeting like note taking stuff, and I got a very good hack of like what are the sub projects, what are running, and like what to ask, like what is going on in the community. So give me a very good idea of what should I ask to someone and how to basically contribute, because while taking meeting notes, I am like fully concentrated on the meeting. So yeah, it is a very good starting thing. Apart from that, SIG docs have like peer reviews that is open for everyone. And then there's a new contributor meet and greet that happens every first Tuesday of the month at 10:30 UTC. You can also find this in Kubernetes community calendar. And always you can reach out to SIG docs and ask that how you can contribute. Then SIG Contribex has quite interesting, exciting opportunities. You can always come and claim a Spotlight blog, and a Spotlight blog is nothing but it is basically you interview sick chairs, and basically you write a blog post on that what does that sick doing, and what are their vision, what sub projects they are working on. And sometimes it happens like project maintainers divide it into couple of series. So we have a SIG enhancement blog which is divided into three parts. I know if I'm not wrong, only one part is published now. So yeah, because the SIG handles a lot of work. So sometimes it divides into a series, sometimes it will be a single block. So yeah. Apart from that, Kubernetes contributor summit stuff is there, but for that, the basic requirement is you need to be a org member, and it happens 2x per year. So you can have some event responsibilities, and that's how you can contribute. Now, let's talk about tasks which come with a certain amount of tech skill. So basically, the thing is sometimes SIGs require someone to work on something. Now, the reason why that issue is open and you can saw it because there is no one in the SIG who can work on it, or if there, they don't have time. That is why that issue is not claimed. So before assigning that issue to yourself, you need to go to the Slack channel and talk to them whether someone is there to guide you, or if you have those skills which are listed for a specific issue, that is fine. If you have that kind of confidence, please go ahead and by all means. But if you are someone who is looking to learn and there is no one to guide you, there's a high chance that issue is not for you. You can ask the maintainers, they will guide you, and then you can learn it and like contribute. But assigning issues with a certain level of tech expertise without having those, seeking someone guidance is not a good idea. The basic idea is that you reach out on Slack and ask the maintainers like how can you contribute and learn on the go. That is how maintainers will have the idea that okay, this person is working on this issue and this is what the time, like this is the time frame for which the issue will be over. So there are certain tech opportunities as well. So we have testing have couple of opportunities. There's an project called Hydrophone where you can do conformance testing and there's a feedback and help enabling adoption of new testing tools going on. So you can contribute to that. Now, blog reviews also require a certain tech expertise where you need to understand the technical topics well. So blog reviews are one thing. Apart from that, Kubernetes localization also requires you to have a certain tech expertise with English and Kubernetes concepts. So yeah, and Sick Contracts is having that website maintenance where you have to have then specific knowledge of the tech stack where it is with you work. So apart from that, there are a couple of mentoring program management where you are supposed to set up and execute a couple of Kubernetes group mentoring programs, and that basically requires some planning and event skills. So yeah, there's a lot, and I will give the link for this slide as well, so you can check them out later. There's no hurry. So and there are some more where you can do hard code contributions. So if you have these skills, feel free to reach out to those six and feel free to contribute. So yeah, these are some of the resources I catered. So definitely join the Kubernetes developer group. Apart from that, also check out the Kubernetes community. And if you are a new contributor, there's interesting guide on cates.dev/guide. You can go there and you can basically have a proper look on how you can get started with it. Again, there's a first contribution guide as well. And This is how you will get your first PR. You can also check it out. And again, there's a whole resources list on the Kubernetes GitHub where you can find the resources how you can actually learn Kubernetes and its concepts. Apart from that, the Slack is there, and I know it is a bit overwhelming, but by taking one step at a time, everyone can learn. So this is all about it, and thank you for listening and bearing me for the past half an hour. So thank you very
Okay.
much, and I hope it helps.
Thank you, Arpit. That was a great talk. And I hope everyone enjoyed learning about this. So I would request everyone, if they have question, we can take that at the end of the session, like after the other part, speakers are done. You can write in the chat your questions, and we will at the end of the session we will redirect it to the speakers so that they can answer. All right, so request everyone to write down your question. In the meanwhile, we can have our next speaker, Krish. So, yeah, you can go ahead.
Okay. So, hey everyone, my name is Krisharan. Is my voice audible?
Yes, it is.
Okay. So, let's present it. Okay, so is my screen visible?
Yeah, yeah, we can see that.
Okay. So, let's get started.
I would also, sorry to interrupt, I would also request everyone to share this link with other team, your friends, family, so that they can also listen to the valuable talks on, cloud native and how to enter all this. And be over this call till the end of the session. We can have some question and answer session as well. Okay. Sorry, Krish. Now you can.
Okay, yeah. So, as I was saying, um, like I'm going to present on topics like GSOC and DevOps. So let's get started with my introduction. My name is Krish Aryan. I'm a software engineer at Webnish. I was 2 times Google Summer of Code mentee at Open Source Rancher and CubeArmor. So I can no longer become a GSOC mentee. And I'm also a certified Kubestronaut and Terraform associated and AWS practitioner. So many people ask what is Kubestronaut. So Kubestronaut is a person who has achieved all 5 Kubernetes-based certifications, that is KCSA, KCNA, CK, CKD, and CKS. So also the organizer of CNCG New Delhi. So if you stay in New Delhi and want to attend like in-person meetups, we host one meetup every month. So you can like look out for our organization. You can search CNCG New Delhi, and you can like join us on Devi. So you can like get notified with every event that we host. Moving on. So today's agenda will be what is open source, benefits of open source. I believe Arpit already talked a lot about open source and like benefits of open source. So I'll focus more on like the open source programs such as GSOC, LFX, uh, MLH, and Outreach, GeForce Asia, etc. Okay, so I'll just skip these because these are the like topics that Arpit already talked. So how to make open source contributions? As you can see, I've opened like project MLflow, and if I want to contribute to MLflow, I can just go to the project and go to the issues tab, and as you can see, there are a lot of open issues here. You can pick one of them in which there are no contributions, like no comments, or like you can check if the issue is open, if anybody is already assigned to it. If not, you can start working on it, or you can first ask the maintainer also that like can I work on this issue? These are my skills. So that way you can just get started working. Many of the open issues have comments in them, so people think that issue is taken. But a lot of times, what happens is that like these the person working on this issue is no longer working on them, so the issue is not getting resolved, and people are thinking that it is getting worked on. So you can just like go on check if this issue is actually getting worked on, and if not, you can start contributing to it if you have the skills to contribute to it. So like uh, better way of knowing whether you have the skills or not like is first joining the Slack, joining many of the projects host a bi-weekly meeting. So you can it's like one of the most recommended practice that you like join the like bi-weekly meetings, and like pin down all your questions in like for that meeting, and you can just ask it in that meeting. Because uh, in Slack channel, like your messages can get like lost because people are busy, and there are many messages going in the Slack channel. So you can like if your question is not getting answered, you can just ask it in the meeting itself. Also, I would highly recommend that please do not ask your questions in the DMs of maintainers. Please always ask your questions whenever possible in public, like in the Slack channel, in the public channel, right? So that like not only the maintainer, other people who are contributing as well can help you out if like the issue is quite trivial. And like these first like go ahead and search about the problem on Google, and um, any open any like AI tools such as like AI chat like Gemini or OpenAI, ChatGPT, anything else. And if you cannot find your answer there, then you can just ask the question like in which you have doubt. So yeah. So if I want to, and also the only way to contribute to the open source i- is not only by just going through the issues. You can create your issues and contribute to them as well. If you know the project quite well, you can do that. So, like a lot of times, the benefit of joining the weekly meetings is that the maintainer can show you the part of projects which needs to be worked upon, but it is not in the issue like tab, because it is a too much hassle to put that issue every time in the like issue tab, and many people work upon it, and many people after working upon it move on to other things. So you can join the weekly meetings, and that way you can get to know about it, and that way you can make your own issue and work upon it. So that's also one way. So yeah, so here if I want to contribute to an issue, I will have to first fork the project here, fork it, uh, then clone it. Cloning is just making a local copy of it, and which is tracked with your fork of the like project, and then like work upon it, create a new branch, commit all your changes and push it to your own branch, and then submit a pull request. And if the maintainer sees that like your pull request is good enough, your pull request gets merged, your changes gets merged, and you can like show other people that you have contributed to a open source project. So why contribute to open source projects is first of all, if you don't have any
So these are the
experience
past programs.
and you
I
need to
was part of
showcase your
2022 4G
skills,
and
it is a very
2023.
good
So
way to
if
showcase
you
your
want to
skills.
see
Uh,
projects
like
that match
it
your
is
skill set, you
like
can just
you can
say
showcase
I'm good
your
at
work, you
React.
can talk
So
about
just
your work with
type
any
React,
recruiter,
and it will
and that way
automatically
you can
recommend me
open source
showcase your
projects.
skills that use
And
React.
after that,
So
uh,
you can
other than
see
that,
there are many
there are
projects here.
many other
If
benefits
I
also.
want
For
to
example,
like say that
you
I'm good at
get to
Kubernetes,
be a part of community, and
Kubernetes.
you learn a lot of
Now you see, like there are only 7 projects.
so um, feel free to mention your skill sets, and it will recommend you projects that you want to contribute. Also, I would say that if there is any organization that is mentioning too many skills, chances are that that organization has many projects. So that organization is mentioning the skill sets of all the projects combined. So you don't need to know all the skills there, you just need to know the skill sets of the particular project. And if you like a project, if many of your skill sets match that particular project, and you don't know maybe say one or two skill set, uh, please don't hesitate and like talk to the maintainer. Maybe it is like niche technology that nobody knows about, like very few people know about, and so the benefit of applying to those projects is that like many people just don't apply to those projects, and you can just learn the new thing, and you can start contributing to it, and you have a higher chance to get selected in that project, and you will get to learn niche technology can help which can greatly help with your uh, like resume building. For example, like in 2023, like in 2023, I did a GSOC in like a project named Rancher. So in 2024, while I was presenting my talk about like my GSOC journey, um, my open source maintainer of CubeArmor was also watching that, and he saw that I contributed to Rancher. So he recommended me that like I should check out the issue that he's presenting it, like he's hosting in GSOC. So I like applied to that issue, and surprisingly, there was only one other person who applied to that issue other than me. Uh, because Rancher is niche technology, and very few people know about it. Like in the beginner space, like if you are a beginner, you might be focusing more on like React and like Linux, Docker, Kubernetes, and stuff, but you might not be knowing much about Rancher. So yeah, that is how I got my second GSOC internship, not internship, GSOC mentorship. So yeah, moving back to our slides. Other than GSOC, this is the uh, CNCF landscape. If you don't get selected in GSOC, you can like check these projects also. These are also very nice projects. Some of them have like huge code bases and are production ready like projects. Some are just emerging new projects, so you can choose whichever you. So as like saw as I told, like GSOC, like contributing to open source mentorship programs is always a good thing, and it helps you to gain skills. It helps you to collaborate with others. It helps you with like your communication skills, and like it builds your network and a lot of stuff. So what these there are many programs like GSOC. For example, there is LFX, that is Linux Foundation Mentorship Program. There is MLH, stands for Major League Hacking, and there is Outreachy. Outreachy supports underrepresented groups of people. So if you are women, or if you are part of any underrepresented group, you can like it is highly recommended that you apply to that internship. Like a mentorship program, and you can learn a lot of new things with your uh, time compensated with stipend. So many of like so open source is not like it's as Arpit said, like sometimes it's paid, sometimes most of the time it's voluntary work. So many people, especially beginners, hesitate to be a part of open source programs because they don't get paid. They see that as a waste of time. So many of the open source programs are there so that you can like explore these open source opportunities while not worrying about your financial financial status or uh, so moving on. So there are many other open source programs like this fellowship, mentorship, Hacktoberfest. There are many, and you can take part in them. So yeah, GSOC also has like 3 tiers of um, like difficulty. So if you don't have much time, then you can opt for easy projects. Easy projects, you will get only $1,000 for the whole duration, and uh, you can in medium you get around $1,500, and in hard projects you get the full $3,000 stipend. So hard projects are like
require a lot of hours, and medium projects get like require half of that, and easy projects are the easiest to do. And if you are not able to do your projects in around 3 months, you can request your time to be extended to 24 weeks, or like there are um, a lot of duration. Like you can maybe choose your project to be extended by 2 weeks, by 4 weeks, or by maybe like 12 weeks. So you have the option there. And it happened in my second GSOC mentorship, that like I wasn't able to complete my GSOC project in 12 weeks due to some reasons. And my mentor suggested, like, instead of abandoning the project, you can just like extend it to 24 weeks. And I did that, and I completed my GSOC like mentorship in 24 weeks. So yeah, but you don't get compensated for the extra time. Say if you are part of a hard project for 12 weeks, you will get only $3,000 completing it in 24 weeks. Yeah. So that's if you are able to complete it in 12 weeks, like just complete it. There's no other benefit for staying around for 24 weeks. And after you have completed GSOC, you can like contribute to other things also in like the community, or you can like complete your project way earlier and start contributing to your uh, project, other parts of it. And that way your stipend will arrive around like the 12-week period, like at the end of the 12-week period. But you can like just do so much more things other than like just leaving the project. So yeah, these are the some stats regarding GSOC. In GSOC 2024, there were 1,220 GSOC contributors from 75 countries. So it's a lot of like diversity here, and like there were 21,000 contributors from 122 countries since 2005. So it's a very good program. It's been thriving a lot, and like there is an acceptance rate of 70.1%. So you have a quite decent chance. Just don't go with the like the most popular projects, because what will happen is that like you will get part of the competition, and there is only a limited seats. So what's the benefit of applying to a project in which there are 100 applications and there is only 2 seats? No matter like you need to be the best of the best in that case. And like you can like apply to a project in which there is almost no competition. For example, my second GSOC project had almost no competition. Like there was just one other person who was applying to that project. So yes, you can apply to those projects, and you can be a part of GSOC. So yeah, I forgot to mention that GSOC, during applying to GSOC and other open source mentorship programs, you get to choose 2 or 3 orgs for your application. So like I wouldn't recommend choosing 3 organizations. I would say stick to 2. Uh, like if you can handle it, then you can go for 3. But I like focus on 1 or 2 organization, and uh, like build my like connection with the mentors, contributed like make some code contributions to the community, and that way my application is way much better than other people. For example, like your application plays a like significant part in getting like accepted to GSOC, but the kind the like maintainers and the mentors are like, and the organization admin are the only person like can that accept your application. So building connection with those people is like quite beneficial. And for example, in my first GSOC term, it was like I didn't make a good application, and my the task was not complete. So I thought that I shouldn't apply for GSOC. But my mentor suggested that no, you should create your application and submit it. It was the last day of the deadline, so I just created a makeshift proposal and submitted it, and I was selected, surprisingly. So yeah, uh, before contributing to GSOC, or any organization, make sure your skills are you're confident in your skills, and that way it will be a lot easier to contribute other than just going to your organization and like from knowing nothing and just trying to contribute. It will be a lot harder. So I would say, like, if you're a web developer, know a lot of things about web developer. You know your stack, know React, know backend, and if you're a DevOps engineer, just study about Linux, Docker, Kubernetes, and various other basic technologies. You can study Go, you can study Python, and that way you can choose your organization and uh, start contributing to it, learn new things. Yeah, this ESOC part of it. And if you want to choose uh, DevOps as your career path. DevOps is basically developer and operation tasks together. So you are bridged between DevOps and operations. Uh, Ashutosh,
Okay, yeah, if you're done with this, yeah, thanks. There was an enlightening talk on how to, get started with
no,
GSOC.
I'm not done. Actually, I think uh, Anurendra has some questions. So, do you want to ask any questions?
Like we can take the questions at the end of the session, like after we're done, final session. That would be good, right? Everyone. So they can write over the chat and I will redirect to you, whosoever is addressed. Okay.
So yeah, if people want to start their journey for as a DevOps engineer, I would suggest checking out Cube Simplify. It is one of the best free resources you can learn. You can start your DevOps journey. And if you decide that you want to be a part of you want to pursue your career in DevOps, SRE, and other roles, and want some place to practice your skills, practice learn by doing, you can check out Code Cloud. Code Cloud is a very good learning platform. It is where I learned my skills and pursued all my certifications from Code Cloud. So yeah, in if you uh, learning through short videos like 5-10 minutes video and then get followed up by hands-on labs, CodeCloud is really the one of the best resource for the its price. So I would highly recommend checking out CodeCloud. uh, and yeah, if you want to ask me questions regarding DevOps, you can feel free to ask. I think I've exceeded my time limit here, so if you have any questions, you can ask me later.
All right. Thanks a lot. That was really an enlightening talk. So now we can ask our next speaker, Murli Mohan Babu, and he can start with. Murli, can you hear me?
Yeah, I think good evening, everyone.
Oh,
Is my voice is audible?
yes, I can see, hear it.
Yeah. Thank you very much. Uh, I'm just trying to share my screen. Let me know if you guys can able to see my screen, right?
Yeah, I see that now. Thanks.
Yeah. So, thank you very much for this opportunity. First of all, I would like to thanks to the Ashutosh and his team. Today I'm just gonna talk about the like a topic called as a. So many people is know about like load balancer is one of the mechanism. So how we can able to manage your load, whatever you are trying to getting your towards your application. But we just need to understanding about like how this is gonna work when you are dealing with this Kubernetes. Okay, so let me introduce myself first. Like myself Murali here. I'm the CEO and the founder of the Client Technologies. Our company is basically dealing with the cloud and DevOps, SRE, MLOps, and apps, FinOps process. Currently we have three customers. All the customers, whatever we have, we are dealing with the cloud products. And you feel free to ask if you have any questions regarding the DevOps or SRE or FinOps MLOps side. I'm just going to start my the topic today. It is all about like the balance scale. We can just try to understanding about like how this is Kubernetes going to understanding about the load balancing mastery over here. See, before I just start my the session, I would like to make you understanding about like how this is load balancer technique it is going to work. See, whenever you have the like you when you're getting the so much traffic towards your applications, we just need to understanding about like how we can able to distribute traffic to the different we can say about like services. See, for that, definitely we have to understanding about the load balance is going to playing a the crucial role. If we are going to deploy the applications on any of the cloud, definitely we are trying to take the service called as AKS. Or if we go to Azure, if we go to that AWS, we have service called as a AKS Elastic Kubernetes Services, Azure Kubernetes Services. If we go to GCP, called as a Google Kubernetes Engine. But we just need to understanding about how this load balancing mechanism it is going to work in the Kubernetes. See, whenever you have the I think the call was disconnected. I think I joined again.
Hello. Yeah,
Uh,
hi. So yeah, I thought we lost. Now I is it like okay?
yes.
Yes, yes, now it's okay.
All right. Sorry for the temporary glitch. Now I'll ask everyone like they can rejoin and yeah, Murli, go ahead.
Yeah. Before we just need to make you understanding about the how load balance is very crucial and how we can able to implemented the load balancing technique when we deploy the application Kubernetes. The first we have to understanding about like how the Kubernetes architecture it is going to work. As we know that like we have there are two things that we have to understanding about. There is something it is called as a control plane, and we have something it is called as a worker nodes, right? So whenever we talk about something it is called a cluster architecture. When you take about the control plane, which is what we can call as a master node, and we can say about like worker node. In a control plane, it's just trying to understanding about what are the components which we have and how this is going to play a very crucial role. So we have something it is called as a we can see about like kube API server, and we have etcd, and we have scheduler, and we have control manager, right? Etcd is basically, about like, where we can able to store your information. So whenever you want to do that API calls, when you do something in Kubernetes, definitely we just need to talk to something. It is called as API server, and we have something called scheduler. Whenever you want to schedule a pod onto the node, definitely the scheduler is going to play placing a very crucial role. When I just talk about the control manager, it is all about like it is going to taking care of the desired thread is equal to actual state of your cluster. That means in control manager we have different types of controllers that we have. We have node controllers, we have endpoint slice controllers, and we have there are the many controllers that we have basically to manage the entire the cluster. So we know that we have the worker node, where exactly you're trying to deploy your application, right? In the worker node, basically we have something it is called as a kubelet, and we have kube proxy, and we have the ports, and we have container runtime that we have. See, right? I just want to talk about something it is called the kube proxy over here, and how this is going to be work when talk about something it is called the kube proxy. I'm just trying to touch down the basics. After that, I'll just show you that how exactly the kube and load balancer mechanism is going to work. So when talk about something it is called kube proxy, the role it is all about like networking components, right? So whenever you have deploy the application in Kubernetes, whenever you want to expose applications or the network, definitely we just need to understanding about like how this the key proxy it is going to be work. See, the key proxy is basically what we have to understanding about the network proxies basically. So whenever you're trying to create in the number of nodes, it is going to run each and every node is in a Kubernetes cluster. It is ensure is basically going to understanding about like all the networking rules, whatever we have, it is currently applied or not, and how we can able to expose the applications. There are, about like there are three services that we have. Usually we do that. We have something it is called cluster IP, we have node port, and we have something it is called as a load balancer, right? So when I just talk about like, the functions, right? We just need to understanding about like, the service discovery, load balancing mechanism, how the networking rules it is going to be applicable. Say for example, whenever there's a pod is goes down, the new pod is getting down, getting created. Who is going to taking care, taking the all the entries, who is coming and who is going out. So because whenever you want to route the traffic to that new pod, how we can able to route the traffic to the new pod. So this all the things are it is going to matter to us. So we just need to understanding about like what's exactly going in the underlying when talk about something it is called as a load balancing mechanism. That's where we have to understanding about like we can able to operate in the user space, or we can operate in like something it is called IP tables, which is very important. Like whenever you are just trying to creating the pods, it is going to have the own IP address. Whenever you are just trying to creating this load balancer, you're going to get the external IP addresses. We just need to understanding about like who is going to taking care of all these things. So when just talk about something it is called as a control manager, it is one of the critical component when talk about in the control plane. See, what is as responsible? Nothing but it is going to run the various controllers, ensures our the cluster is going to match the desired status. So each controller focus on the specific aspect of the clusters. See, what is the key functions when I talk about the control manager? So because the first we have to understanding about like it is make sure the actual state of the resources match the desired state of what we have defined in the API server. This is the primary job of the control manager. It is always going to maintain the desired state is equal to actual status, and it is going to handle the failed nodes, or we have to understand how we can able to do the port recovery, how we can able to perform the resource scaling. So all this is going to taking care of and just talk about something it is called as a the control manager. As I mentioned about earlier, we have different types of control managers that we have. So there is something it is called node controller. We have replication controller, we have endpoint controller, we have the service account and token controllers. See, whenever you're trying to creating the service in a Kubernetes, it is going to creating endpoints on each and every pod, right? So we just need to understanding about like who is going to maintain the entries. So for all these things, like these are different types of controllers that we have when just talk about the control manager. So whenever you're trying to creating the cluster on the any of this particular the cloud, definitely we have something it is called the cloud. The control manager is going to playing a crucial roles. See, when you talk about something, it is called as the load balancers, the different types of load balance techniques that we have, right? So we have something it is called as application load balancer. We have something it is called as a network load balancer. We have a gateway load balancer, the different types of load balancers that we have. So we just need understanding about like when you're trying to creating a load balancer, it is going to work on which layer, how the functionality is going to work, what is the costing perspective. See, right now, you guys are just like, understanding about load balance technique. But when I'm just going to talk to the client, when I go for any client meeting, they really bother about the cost. So that is the reason we just need understanding about like whenever I'm just trying to creating the applicable load balancer, how much cost it is going to be cost as. And when I just go for the creating load balancer, what kind of traffic it is going to distribute, how much it is going to cost to the client. Because the cost is one of the major factor right now in the market, how we can able to reduce the cost to every client. That is where the something which we are trying to doing something it is called as a the FinOps side here. So when I talk about the application load balancer, this is what we can call as a L7 load balancer is basically work on the layer 7. It is basically it's going to receive the traffic, which is the coming is nothing but HTTPS, or we can say the HTTP traffic. We just need to understanding about like how it is going to be charged. It is basically going to charge like in a per hourly usage, load balancing capacity. I mean to say the unit, which includes factor like how many requests it is going to processed and how much its bandwidth that we have, how many active connections that we have. So typically this we have to understanding about it is going to be more expensive, compared to network load balancer to the advanced features whatever we have. So when I go something, it is called network load balancer. So for example, you are trying to creating the load balancer, when you just go to AWS, but you don't know about that inside how it is going to operate, right? This is where we have to understanding about like it is going to create something it is called as a network load balancer. Basically, it is going to operate on the layer 4, which is going to handle the TCP, UDP, and TLS traffic, whatever it is coming here. So it is basically we have to understanding about like what is a use case. It is the basically going to design for the order low latency, which is nothing but a high throughput use cases. Example like we have to go for the gaming applications or real-time financial systems, whatever we have. So the basically we have to handle the traffic which is coming to the TCP and UDP. Definitely we have to go for the layer 4. It is going to be charged per hour usage and per how much like the process GB of data it is going to be charged. So generally it is going to be less expensive when you compare to the application load balancer, and it is going to be high performance use cases also we have. So very high. So whenever you're trying to implementing any load balancer, you have to understanding about like how much cost it is going to costing to my client. This is a simple architecture which I want to talk about like see whenever you're trying to creating the load balancer, nothing but application load balancer where actually which is going to handle the HTTP and HTTP as request, right? But internally, what is happening in this particular application tier, where it is going to be created something it is called as a network load balancer, because it is basically tells you about like how we can route the traffic inside the application. So, but we think that only we have created application load balancer. We are not worried about much like what is going to be happening inside the application, how it is going to be route the traffic in all this. This is basically how they have designed, in underlying infrastructure. That's where which is, it is going to creating something it is called as internal, what we can call as a network load balancer. If you look at this architecture, clearly it is talk about like, this is what we are trying to creating something it is called application load balancer. When I say something it is called internet facing, that means all the traffic, whatever it is coming towards my application, basically it is coming from this particular, internet, right? So whenever the request goes inside the application, how we can able to route this particular traffic, it is inside. It is everything. It is going to taken care by the network load balancer. See, for example, I have deployed a small application like a Kubernetes cluster. See, I have the setup already, the cluster, everything. And look at here, I have a setup something. It is called as a Truner cluster. See, for example, if we just go to here, when type the command called kubectl get nodes, I have two nodes right now we have. So when I just type the command called as a the kubectl get deployments, if you look at my screen, I have the two deployments that we have deployed. One is something it is called as a user profile. Other one is something it is called as a MongoDB that we have done, right? And after that, what we can do is it. If you just look at my screen, if you type the command called as a kubectl and get SVC. I have deployed the application, but I wanted to expose the application over the network. So whenever I want to expose the application over the network, like what kind of mechanism that we have done. See, if you just look at clearly my screen, there is something it is called as a MongoDB server, which type it is something it is called cluster IP address. And when I just look at here user node, which is nothing but my front end application, when I just wanted to access my application over the internet, I have just created something, it is called load balancer, right? You just look at here, there is something it is called cluster IP address also it's created. And also there is something it is called as external IP address also got created, right? This is nothing but my load balancer URL. And this is nothing but my port number and which port number I want to expose my application. But the many of the people they don't bother about like what it is exactly, what is the port number, why it is created in all these things. See, whenever you are trying to deploy the application in Kubernetes, whenever you want to access the application over the network, whether you go for the third-party load balance mechanism called as a HA proxy or Nginx, if there are go for the any third-party load balancer mechanism, or whenever you want to expose the applications by using load balancer, this is what we can call as external load balancer, which is going to provide by the cloud provider. It is not provided by the Kubernetes. See, whenever you are trying to creating any load balancer in Azure or GCP or AWS, it is basically going to provide by something it is called as a cloud, a native, the provider, right? So, but I want to ask a question like you are accessing the application with this URL and the port number 3130, right? See, for example, if I'm just trying to fill my details, I'm just trying to perform the registration. Let's say, for example, I'm just trying to put my look at my screen. I've just put my email address. I'm just putting this particular the phone number, and after that, I'm just trying to perform this particular, entering all address and all these things. After that, let me just try to provide the password, right? So when I click on the register right now, you can just look at here, the registration is successful, right? It is asking us to provide the email, and it is going to asking us to provide the password, right? So when I provide this factor the password, when I just click on the login right now, so it is asking us to enter the OTP, right? I mean to say I have just implemented something it is called as a OTP. So let me just going to enter the OTP which I have received to my which I have received to my email. See, for example, the OTP it is saying about like, the 73. And if you just go for the 427, when I click on this login page here, it is going to verify the OTP and it is going to take me to inside my home page of this particular application, right? So when I just go for the home, and if you just go for the about us, if you go for the services, so this is everything that that like I have deployed the application. I'm just trying to accessing my like an application to the like load balancer external IP address. We can say that that this is going to be mapped to your domains. Whenever you type flipkart.com, it is going to hit this particular URL. We had to configure the backend. We had to create record all these things that we could do that, right? So this is nothing but my application which I deployed. See, whenever the more customers are trying to access my application, how this is going to be route the traffic inside the cluster? That is what my question is right now. So if you just look at my screen, this is nothing but my, the service port number. This is what we have to understanding about something. It is called as a node port number because this load balancer is going to create the external out of the cluster, but it cannot able to route the traffic inside the cluster. But how this is going to be route the traffic inside the cluster? That is what is my point I would like to explain over here. See, if you look at my diagram that what we have mentioned, this is nothing but my load balancer IP, and we have put the service port number. See, the moment when you are trying to hit the URL, the request goes to where means the first request go to your node port service. As I mentioned earlier, like Whenever you want to expose the applications in Kubernetes, there are three kind of services that we have. One is nothing but cluster IP service, and one is one thing node IP, node port, and we have something it is called load balancer, right? Whenever you are trying to create a load balancer, it is going to create the external load balancer, which is going to provide the cloud provider network. And here, if you just look at here, it is going to open this particular port number called as a node port number. Because why? Because node port, it is going to expose the application over the top of the node. So it is going to route the traffic inside this cluster. We can see that this is all my node, right? It is going to open one static port number in top of each and every node. Whenever you send the request first go to your the request first go to where the request go to your node port service. From node port services go to your endpoint. So whenever you are trying to creating the any service, it is going to create the endpoint. See, for example, if you look at my screen, when I type the command called as a the kubectl get pods, you see the board like how many pods that you have. So I have total the 5 pods are running. So when I just type the command called kubectl get pods hyphen -o wide, when I mentioned, you're going to get the 5 IP addresses, right? So now if I just type the command called as a the kubectl get svc, I have this particular service port number. When you type the command called kubectl describe, and when I mentioned about like SVC, so I'm just trying to put something. It is called as my service port number. Sorry, my service name. I'm describing my service name. Okay. So if we just type describe, we can see about like load balancing address is got created. And you just look at here, this is nothing but endpoints. See, this is nothing but one endpoint right now. This is another endpoint. This is the another endpoint. That means my what are the front end application that we have? This front end application is basically I have deployed in the 3 pods running. So on each and every pod, if you look at here, there is one endpoint it is got opened. So it is showing about like 192.168 dot. You can just look at here 19.156. If we just match this IP address over here, it is going to be match. You see that one is something it is 156, and we have 76, and we have 78. These are the IP addresses, whatever we have, it is got created. And look at the, this is what is nothing but my service port number. See, this is nothing but my node port number. Okay. The request is basically it is comes towards your node port service. From node port service, it is goes to your endpoint. See, as I mentioned about the why we are going to use node port service means we want to expose the application over top of the node. So it is going to route the traffic inside this particular cluster by using something it is called as a node port service. And internally, it is going to use the load balancing mechanism for the using this factor, the cluster IP address. This is exactly that how this is going to be route the traffic when you talk about something it is called as a how this is going to work when you're going to use something it is called a load port service in the Kubernetes service. If you look at these points that what I mentioned over here, if you just look at here, the external load balancer, whenever you are going to create it, it is going to create the outside the cluster. It is going to listen on the specific port numbers. It is going to forward the traffic to the nodes hosting on the corresponding pods. The traffic it is going to route it using the node port service. It is not going to route the traffic by using load balancer. So this is something that we have to understand everyone. That is the reason I just brought up this small topic. I want to explain so that you get understanding about like how it is going to work in a underlying infrastructure. So this node port service, whatever we have, this node port that are automatically managed by the Kubernetes. See, when I created a Kubernetes service, I didn't mention about like need to create node port service. I mentioned about only to create a service port number. So service port number, I want to expose my application, but who created the node port service? The node port service is automatically be created by the Kubernetes. See that the cloud provider's load balancer may also perform the health checks on the nodes. The pods ensure the traffic only send to healthy instances. You know that load balancer will accelerate external traffic. It is going to route to a particular node. So, but before it is going to send to a particular node, it is going to check the health of the server, right? That is, it is going to do it with help of the ping request. That is how it is going to do that. See, the load balancer itself is external to the cluster. typically it is going to manage by the cloud providers. So whenever you have the multiple services, when you want to perform the path-based routing, or when you want to perform the domain-based routing, definitely we have to use something. It is called ingress, right? You might aware about like Nginx and HA proxy. It is also going to provide another cloud provider. It is going to provide the load balancer. This is what we can call as a third-party load balancers. You might heard about the FI load balancers. See, for example, you might guys using the railways, right? ircities.co.in, you are going to use to book the ticketing system, right? And we have the passenger railway ticket system that we have. So this application is basically going to use FI load balancer, because when I have been to Delhi, when I visited there, the CRIS, nothing but Central Railway Information System, I have trained them for the DaySecOps in that project. I had chance to visit their data centers. I've seen how the data centers, what load balance they're using, and how much storage they're using. All these things. I got a chance to use that. So, but they're using Red Hat OpenShift. To that, they're using the FI load balancers. Is that the Kubernetes does not create load balancer within the cluster. It relies on the cloud provider's native load balancer infrastructure. It is basically created by the who it is going to provide by this Spectre, the cloud providers network. So if you're running Kubernetes on bare metal in on premises, or we can see the platform without cloud integration, so we need to set up a load balancer manually, or alternatively we have to use this Spectre metal LB, or we have to go for the third party load balancers. That is how we just need to do that. This is how we just need to understanding about like it is going to work load balancer, route the traffic internally inside the cluster. So I hope you guys understood, right? If you have any questions, I can take up your questions. I can able to the clarify all your doubts.
Okay, thank you, Murli, and that was really an enlightening session. And all our speakers have delivered a good talk. So it was our first CNCG Dehradun, you know, event, and we hope everyone liked it. And with your participation, we were able to, make it really nice. And now I would request everyone they can put in their question over the chat, and we will ask respective speakers to answer it. Okay. So, and yeah, the concluding session will be done like by Mohit, my co-organizer. So he'll be speaking to you. So before that, if we have any question, you can put over the chat, and we can ask. Or if you want to ask also, you can ask. Over to you, Mohit.
I think someone asked, I wanted to ask what qualities do mentors in GSOC look in proposal? How we can make good proposal? I think the question is for Krish.
Like proposal, I would say that like proposal is only like you can say like 20% of the weightage of your entire GSOC journey. I would say that like you should focus more on like contributing to the issues, engaging with the community, joining the weekly meetups, and talking about like your what problems you are facing, what how you are implementing the solution, and that kind of stuff. And whatever work you have done in that period, say 1 month or 2 month, you can write that in your proposal, what you can write about your contributions, previous contributions, and like how you are going to approach the like issue, the GSOC issue. So so and there is like code implementation also there. You have a like plan to implement the solution, like how you are going to do that. So you need to write it down in your proposal. I would not say to make a proposal more than 20 pages, but like you can make if you mention all of the things about yourself, your past contributions, your skill sets, your um, like how you're going to approach the problem, like the GSOC problem, uh, I think it will like easily surpass around 10-15 pages. So yeah,
Other we have from Abhinav. Please share all the links PDF. I think he's talking about Arpit PDF about Kubernetes. So Arpit, can you share the links, the important links in the chat box?
Yep. Second. So I will do one thing. I will upload it to my GitHub and then I will provide you with the links. So
Yes, you can
you
provide that
can,
link. Hmm.
yeah. So I can do that right now, but it will take like some minutes.
Or you can send me later. I will share the link in the WhatsApp group.
Yeah, that is fine. I think you can post it from the CNCF Dehradun handles. I will provide you with the link, and I will also post it from my LinkedIn. So no issues with that.
Next we
But
have.
for
Mhm.
now, I
Yes.
have sent you. For now, I am sharing the Canva link in the chat. So yeah,
So if anybody have any question, you can ask directly to the speaker, or you can post in the Q&A if anybody have any question. So another question is for the contribution to a CNCF project, a necessary requirement to get selected for LFX. I am preparing for LFX. So I think this question is for Krish. Hmm.
in LFX, it is not necessary that you contribute to CNCF projects. LFX in LFX, there are projects from other communities also. CNCF is a part of Linux Foundation, so you might be getting projects from, let's say, I don't know which community to mention here, but yeah, it is not necessary that you will get projects from CNCF. You can get projects from other communities as well.
Yeah, I think
Maybe
L-
you can get a kernel development project. So yeah.
yes, I think they have multiple organization. I think Hyperledger also take part in
Yes,
LFX. So you can.
yes, that's a great example.
So someone asked, I am in second semester. Should I start learning DevOps first or data science, which should be more beneficial? Huh.
I
I
would
think this is.
suggest that
Hmm.
yeah, sorry.
I think like
um
if everyone can speak on this topic, all of the speakers, if they want to share, Murli sir, if you want to say something to the freshers also, you can also speak.
Yep, sure. The question is like, I wanted to start data science or I wanted to start the DevOps. Here is the very quick question. So, when you want to learn this particular DevOps, I have two sessions for you. The first, you have to understanding about the network fundamentals. This is where the many people will missed out. When you're dealing with the DevOps, most of the times we're setting up the pipelines, we deploy the applications. So many things we are dealing with is something it is called a networking system. So you have to understanding about a very good. You should learn first networking fundamentals. Then I suggest you to go to learn the first any of the cloud. After that, you start learning the how to automate the infrastructure as a code by using the Terraform or the Pulmy. You choose the tool, whatever you work. Then we can just go for the DevOps. See, whenever you wanted to learn the DevOps first or data science first. See, right now the market is basically about like it's going to AI. So whenever you wanted to create the LM models, definitely, we just need to learn something. It is called data science. Again, when you want to learn data science, again, you have to choose something. It is called the Python. See, whenever you have developed any application, data science applications, by using Python or something like, obviously we have to use the to the cutting edge where we can deploy in this something it is called the cloud. See, right now we have a client where we are dealing with one AI agent for the banking product. See, we deployed on the Azure, nothing but AKS side we had deployed. For that, we have again taken the GPUs. We are running these particular models on these particular GPUs. What are the models they have created, and we deployed all the models on GPUs. So this is two things that we have to understand first clearly. The first, learn data science, how we can able to develop the applications by using Python or AIML, whatever you have choose it. After that, then start learn the how we can deploy these applications by using the DevOps pipelines on any of the cloud. See, but end of the day, whenever you deploy any application, definitely the what I'm just talking about AI models. So whenever you want to deploy any of the AI models, definitely the cutting edge is nothing but the cloud. So definitely we have to do the automation for that. So learn the Kubernetes, Docker, and learn something it is called Helm chart, Argo CD, and GitOps is right now in the market. And use something called Tekton for CI. These are the tools. The basically it has the very high values in. I mean to say high demand in the market. The first learn the how we can build the application, then learn the networking fundamentals, start learn the cloud, then go for the DevOps tools. That's my answer for your question.
So others also, they you can also say on.
Yeah. My take on, am I audible first?
Yes, you are.
Yeah. So my take on this is if you're in second sem and you are deciding like whether you should go for DevOps or you should go for data science and ML stuff. My This is completely my opinion. My advice would be like keep yourself open to different technologies, because at the end in industry we are using everything. There's nothing at such, like I have friends who are earning very well in uh, data science field, and I have friends who are earning very well in DevOps field as well. So like if you are deciding like whether you should go for DevOps or whether you should go for data science and you are in just second semester. So my advice would be to explore the DevOps technologies, try to use the tools, try to like uh, run DevOps projects locally. Like if you find out any project on the GitHub and you would like to contribute to it, try to run it locally first and decide whether you are enjoying it or not, whether you are enjoying the process or not. You can do the same with data science as well. There are open source project with which require ML contributions. So again, every see there are too many technologies, like open source have too many technologies of offer, and you can contribute in every way possible. So try to explore some projects which have some DevOps things to contribute, and try to explore some projects which have some ML AI things to contribute to, and explore, find out like what you are enjoying more, and decide on the basis of that, because you are in second sem. There's no hurry, so don't get stuck on one thing, because what I find is that in industry everything is useful, every technology is useful, and that is why that is there. So I would say try to explore things, try to get engaged with the community and decide on the basis of that. If like there's not a concrete answer like, okay, data science will be more beneficial or DevOps will be more beneficial, or like there's now AI is coming out, so people are now talking about AI agents, but that does not mean that people who are doing Java are obsolete. They are doing it and they are also earning well. But the thing is, you need to find out what you enjoy, and you need to set a goal. But as you are in second sem, be open to exploration, and uh, take your time to decide what you want to pursue as a career. Don't make it don't make that decision in a hurry. So I would say to explore couple of DevOps tools and couple of MLAI projects and then decide. try to contribute to both of them, and don't fall for that pitfall like, okay, I will do this thing for a month. Give at least 3 months to something. Like if you are saying, okay, I will explore DevOps tools, so give yourself a significant chunk of time, like 3 months, and explore it, and then decide whether you want to do it or not, and then move on to a different thing. Don't hop. This is what my advice is. Take one thing at a time and explore it. So that is what my take is. Uh, yeah, everyone
Okay,
else.
Krish, you want to say?
I basically agree with both my co-speakers. Like I would like say that do what you want to do. Like explore the like both data science and DevOps world and see if anything clicks. And like if you like one of them, you can just like follow a roadmap, or like you can go to roadmap.sh, or maybe check out Cube Simplify, maybe roadmap there. You can go to like Code Cloud also. You can get a curated like a baseline of things that you want to learn, and after that you can just start building your projects, and that way you can get into DevOps. For data science, I don't know what's the roadmap there, but you can find plenty of people by like joining open source communities. They will help you like getting useful, like getting to know about useful skills in data science, and you can stay ahead of the curve than the rest of the people who just don't know about like these communities.
Yeah, very well insight. I think I agree with most of the speakers because I am also a corporate trainer and I help freshers getting job, And what I've seen is like they, hop on between the technologies very in a short period of time. Just devote some time to a technology, and like Murli also said, everything is useful. Like data science and this cloud can be combined. You can work on a big data, and that big data will be in some of like you'll be using a pipeline. And I have also worked with many clients in such projects. And moreover, it's about getting stick to something, and eventually the job will flow, because we are more worried about job these days, what I observe from fresher, rather than uh, instead of like it's okay to worry about job, but should worry more about the skills, that you have something, differentiator, a unique differentiator. Like everyone is building Netflix clone these days, so don't go for that. Just look out your home project, something like you want to automate maybe your alarm system or something, just hypothetically, and use DevOps or whatever the technology you're learning. Maybe you can help some nearby guy, who nearby NGO, or someone like a farmer, and help them use AI, and all sort of things, build their websites, and then use all kind of technologies over there. Then whatever interest you find more, just pursue that. And moreover, whatever because what I have seen from my experience, whatever you'll be learning in the college, that you have to unlearn few things, because in industry doesn't work like that. Like there are SOPs which you have to follow in the industry, however in the college, and when we are just starting out, we don't follow that. We just write code like this only, and I mean that causes a problem. So just uh, from learning, like we have to unlearn also few of the things. So we should be open for feedbacks, and we should not be brittle. And yeah, that is what my advice is. And yes, we do have cloud openings in many companies these days. But yes, with the inception of AI, the developer jobs are getting less. That is for sure. No one can deny it. But at the same time, like initial level cloud jobs are there, like cloud infra engineer, and I've seen many in like system associate system engineers. Yeah, that is there. So, and any other questions we have, Mohit, or we will conclude it? Hello. Okay, so do we have any other questions? All the one who are participating, like you can ask. And then one last question, then we can wrap up this.
If anybody have any question, you guys can ask, or you can simply ask the question in the Q&A session. I think we can bind up the session. Thank you so much for joining this session. Special thank you for all the speaker, Arpit, Krish, and Murli sir for joining us. And this was a first event for the CNCG Dehradun, and we are looking forward for more session. And we are also thinking to do a offline event or a launch in March and May. If anybody student or if anybody wants to join the team, you guys can reach out to Ashutosh Bhaiya or you can reach out to our page. And yeah, that's all from my side. Ashutosh Bhaiya, if you want to add something, you can add.
Yeah, so like I want to thank everyone who gave out like precious time and over the weekend. I know it's not easy, and thanks, like heartfelt gratitude to everyone, to all the speakers, Murli, Krish, and Arpit. So it was really a great session. Now, like even I learned few things from you guys. So it's all about learning, and I hope the audience also enjoyed it. And it seems like although we have less number of people joining today, so we will plan it accordingly. Like we can have an offline, event coming soon, and everybody can, you guys are also welcome, and we will. Because these days it's very cold in Dehradun and it's like tough to manage the logistics. But yeah, soon we will plan something big, and would look for everyone's participation. If you want to volunteer, there is a link which you can go through, and or you can directly reach out to me over the LinkedIn, you know, and also share with your friends, families, and be a part of a revolution which is happening in Dehradun, Uttarakhand. So, and yes, so we are trying to bring this cloud native space accessible to everyone, those who even who can't afford it. We will try to bring some more opportunities, so that they can work on. And yeah, we should be like, because more importantly, last but not least, I want to say being an engineer is good, but being a good human being is more important. So we should be courteous, and we should be helping each other, our uh, teammates, our, so share and care with them, and take care of your loved ones. And yeah, thanks for joining again, and have a nice weekend. Enjoy. We'll see you again. Thank you, everyone.